Okay, good day, great cough. Okay, so we are looking at hyperbolic functions, okay, in the form of 1 over x. And what we do have here is that we're going to do the transformations of graphs of functions. You're going to see how we determine the domain and range, the axis of symmetry, and also how we're supposed to sketch. Okay, then lastly, finding the equation given the graph. Okay, so let's get started and see what's happening there. All right. Now, so your hyperbolic function is in the form of what is it? This is what we have here. F of x is equals to 1 over x. So not 1 over x as such, a over x, okay? A over x. So in this case here, this is the standard, okay? This is the standard, what you call the standard graph here. And we're going to start with the effect of A, okay, on your graph. And remember here that your A does what you call your A, if it's negative, that's where the problem is. So it only what the effect there is the sign for A, that's what matters only. The rest doesn't matter. Okay, so generally when your A is above, when A is above 0, meaning when A is positive, okay, in other words, let's say it's maybe 2, y equal to 2 over x. Your graph generally it falls in the, this is what you call the first quadrant, okay, and you've got the second quadrant, you have got the third quadrant, and you've got the fourth quadrant, okay? That's what we have there. So that one is first, second, third, fourth, okay? Now, what it means here, it means that your graph is just like that, okay? And it's just like that, okay? So if A is positive, okay, your graph falls into the first and third, always remember. Now, here, for this one here, what you call, if A is less than 0, meaning A is a negative, and in this case, maybe we can say f of x or y is equal to negative 2 over x. Now, in this case, now your A is negative, and which means your graph will fall into the second and fourth, okay? Second and fourth. So I don't know what you should do to remember this, okay? But just know that this one it has to fall under first and third, okay? That's what we have there. That's what we have, first and third quadrant, okay? Quadrant, and that's what you need to remember there, okay? So here, what we have here in this case here, remember generally the graph, what the graph is like, it's f of x equal to a over x. And you know that if we say anything over divided by 0, what happens? Anything divided by 0, if we say 9 divided by 0, it tells you what you call divided by 0, it tells you what you call what is it, error, okay? It tells you error. It doesn't happen like that. So it means that your graph must not touch x, y equal to 0, okay? Y equal to 0, so x cannot be 0. In this case, x can't be 0, okay? So it can't be 0. In this case here, it means that the y-axis, the x-axis, it doesn't touch the x-axis. That's why you see it hanging there. Now, also again, in terms of the y, okay, in terms of the y here, if we say y equal to a what you call over x, and to find y as well, it becomes also a challenge, okay, because if if x goes to 0, we can't find y, okay? If y is equal to 0, we find x. So in this case here, x can be 0 and y can't be 0 either. So in this case here, the asymptotes in this case, where it doesn't touch those, it's both x, y and x what you call x's are asymptotes. So that's what you need to remember. So generally, in terms of the domain, okay, domain in this case, the domain, okay, domain for x, as you can see that the x can be any value, except 0, can be any value, can go from here going up, can go there going down there. So what you can do, your domain, you can say x not equal to 0, then x element of real numbers. Okay, yes, it's element of real numbers, but it's not equal to 0. Or you can say, what is it? What is it? X less than 0 or x greater than 0. So these actually are the what called the domain that you see there, because it can't be 0. It has to be less than 0 or greater than 0. Okay, that's why you say it mustn't be equal to 0. So you either give these two, or you either give these two. It's up to you. Okay, then the range for this range in terms of y, again, is still more or less the same, because what we have here, y cannot be touched. Y cannot be touched, but y can occupy any value as well, because y, you can see that is going there to infinity, there is going also to infinity. So what it means there, it means that y cannot be equal to 0, and y element of real numbers. Okay, then again, or you can say y less than 0 or y greater than 0. So that's what you can have here. That satisfies your what you call your general, your standard equation there. Okay, so that's basically what we have with the originally with the standard equation. Now let's move on to the form of when we transform it to f of x when it's equal to a over x plus q. Okay, a over x plus q, and remember again, q is the vertical shift. So if it is plus q, it means it's upward. Okay, if it is negative q, there is downward. Okay, so what it does here, it just shifts the what called the asymptote. And remember something here, q is the y asymptote. Okay, q is this asymptote as well. Q, okay, is an asymptote. So your graph will never touch q. So another thing, that if they ask you asymptotes, you must know that already q is my asymptote. Like in this case here, when q is equal to 0, when q is equal to 0, because this one is more like plus 0. And when it's plus 0, it means that your asymptote is 0, like what we said here. Those are that asymptote is equal to 0, x is equal to 0, and y is equal to 0. So equation for the asymptote in this case, equation for the asymptote is x equal to 0 and y equal to 0. These are equations for asymptotes. Okay, that's what we have there. Then, so q is an asymptote, okay, and it just causes a vertical shift. Let's give an example here. Let's say it's f of x is equal to 2 over x plus 4, okay, and let's have another one to say maybe f of x is equals to negative 2 over x minus 4. Okay, now and see how what we get there. Okay, now let's draw our graph there. We said plus 4. Okay, Now, where are we here? We have 0 here, and we put our 4, and we know that our 4 very well, that our 4 is our new asymptote, and in terms of x here is still 0, so we don't need to stress here. It's still gonna be 0 here. That's the point of what you call point of asymptote there. Okay, point of your asymptote, or we're supposed to draw it with the dotted lines, but it's fine. That's y equal to 4. Okay, and this one is asymptote. Okay, and in this case here it's positive, so we know that it's fall under, it's actually above here, and the other one is down here. Okay, remember we're not sketching, we just, it's just a sketch, yes, but it's not a proper sketch. Okay, so don't copy this and sketch it like this. We're just trying to show you here generally what actually the effect of q does. Okay, what q does to equation. Oh, didn't see that happening, but it's fine. Hope you guys, you can see here. We're saying it's minus. Okay. Okay, now we're saying minus 4. So we move again to minus 4, and minus 4 becomes asymptote. So that's what are we supposed to draw it. Y equal to minus 4, that's an asymptote. Okay, now we have got origin, and we're saying it's negative. So it's negative falls in the third quadrant, the second and fourth quadrant. So it's gonna be like this. We're done. That's what you only need to remember here. So that's how it's affecting. So you shifted 4 units downwards. Okay, your graph just shifted 4 units downwards, and again in this case your graph shifted 4 units upward because of this. So that's the effects of q. Okay, so let's see another scenario again here. Okay, the equation, if f of x is equal to a over x plus p plus q. Now we have something new here. We have something new here. What is new here is p. And p, what did we talk about p? P is it's a horizontal shift. P horizontal shift. So if you really, if you attended the quadratic function, the function 2, okay, my lecture, you actually see that I have indicated this, what is the effect of q, what is the effect of p, and it's still the same here. What we're doing here, we're doing still the same, and you just need to understand which nothing changed. You just need to master which, when you're having x plus q, what happens there. What happens is that it's actually causing a horizontal shift in the x-axis. Okay, in x-axis. Okay, x-axis. And again here, when it's plus here, when it's plus you move to the negative, when it's minus you move to the positive. So what am I saying here? What I'm saying here is that when it's like this, okay, when it's like this, the asymptote here, asymptote, or should I say asymptote? Let me see here. If we are to draw something here, let's see, f of x is equals to 2 over x, okay, plus 3 plus maybe let's say 9, okay? Now, we don't want to get 0 here. We don't want to get 0 here. So what must we avoid here? We don't want to get 0, because if 1 is 0, it becomes undefined. So we're going to say x minus x plus 3, okay, is equal to 0, okay? Then x is going to be equal to negative 3. So these 3 that give us 0 is what we, negative 3, that what we don't want. So this becomes asymptote. This becomes the x as the x asymptote, okay? So it means that you have moved your graph now. So let's see your original graph here. Original graph there. Let me see here. Just gonna draw 2 graphs, okay? And let's draw the other one here, the other for the final. Okay, I'm doing this. You must also be doing that when you are sketching anything. Okay, so now remember, what did we say here? We know that the general, let's draw something here. I'm just going to draw here 2 over x plus 9. Okay, 2 over x plus 9. Okay, so I'm just going to say, all right, 2 over x plus 9, we know that is 9 units. Let's say y equal to 2 over x plus 9. Okay, let's have another 9 here. Okay, then we say that's our asymptote there. Okay, and we have an asymptote there. X is going to be equal to 0. We don't want x equal to 0. So where is x equal to 0 is the y-axis. So we keep it like that. Then we're going to know that a 2, is it negative, is positive. So where does our graph falls? It falls under these 2 quadrants. Now in this case, now what we're going to say, all right, we're going to say, all right, we have got, sorry, before I go, asymptote here is x equal to 0. Okay, that's number 1. Then the other one is y equal to 9. Okay, that's what you need to know there. Those are the 2 asymptotes that we have. Those are equation of what we call asymptote. Now here we're going to say it's y equal to 2 over x. F of x is equals to 2 over x plus 3 plus 9. Okay, plus 9. Okay, now we're going to say, all right, we have 9. 9 is the first asymptote here. So we draw our 9 because we know that Q is an asymptote. Now we're told that it's x plus 3, and we told that x goes negative 3 is our asymptote again, negative 3. So here, at this point here, this point here is where these 2 graphs actually, these 2 asymptotes meet, and from there it's positive. So you're going to draw your graph like this. Okay, and draw your graph like that. And as you can see, now your graph can touch the y-axis. Now your graph can touch the x-axis. And you need to remember that when you are doing a sketch, when they ask you to find the sketch, you must be able to calculate the asymptotes here. Okay, sorry, man, not the asymptote, the x-axis, the axis here, the intercept, y-intercept and x-intercept. Okay, you must be able to calculate that. So that's what we have there in general. That becomes our equation there. So you must always remember that you moved, when it's plus 3, you moved 3 units back. Why are you doing that? Because we don't want to have a negative, we don't want to have a 0 at the bottom there. So you just need to equate this to 0 to get what called the y, the x asymptote. To equate this one to 0, then solve for x, because it might be maybe 2 over 2x plus 4. So you need to make sure that you equate that to 0 so that you can find the value of x. In that way, that value of x must not be must not be included in your graph. So it must be approached but never touched. Okay, that's what we have there. So that's how we're supposed to draw the equation of y is equals to ax, y is equals to ax, a over x plus b plus q. Those are the effects that you need to remember there. Okay, so point of intersection of asymptotes. Asymptotes is negative p q. Remember, it's just like the turning point that we did previously. What we did previously. So here your p is what? Your p is 3. So it's just negative 3. That's what we have here. And you just pick the q. That's it. That's how you get the point of intersection. Okay, that's what you get, the point of intersection. Okay. Now let's move on to to something else here. Okay, so here is the general graph here. The standard graph of f of x is equals to a over x. Okay, where we are saying what is it? What is it? These are the asymptotes that we have. Okay, so we spoke about the asymptotes, and I hope you guys understood. Now we're talking of axis of symmetry. Axis of symmetry is the line that imagine a line that separates your graphs into mirror images. So we've got two axes of symmetry here, two axes of symmetry here, two times you have got two axes of symmetry here. So the first one is the positive one with the positive gradient, which is equals to y is equals to x. And then second one is y is equals to negative x. So these are the two lines that you always need to remember. So whenever they ask you axis of symmetry, in this case, you must always remember that it's y is equals to x and y is equals to negative x. Okay, that's what you need to do. So for a standard function, for a standard hyperbola, you just know that these are the what you call the what is it the values. Okay, but now let's see if you shift your parabola, what's going to happen now. So if we shift, so for shifted hyperbola, what happened, which is f of x is equals to a over x plus p plus q. What happened to the shifted hyperbola? A shifted hyperbola, you know that point of intersection, okay, those two lines, these two lines, the what you call the two lines here, two lines of symmetry meet or intersect, yeah, meet at negative p q. Okay, so these two lines meet at negative p and q. So if ever you draw something or you find something that is actually what is maybe that is not in the what you call, that is maybe shifted. Okay, you know that, all right, how am I going to find my equation there? I just need to check, right, what is minus p and q, minus p and q. Then from there you substitute in the equation, because the gradient, their gradients remain the same, the gradients. So for this one is continue to be, so for the first one it becomes, let me show you something here. So here let's have something like this, so that we have a better understanding, because maths is need to be shown what's happening here. Now let's say you have something like that. Okay, so we are saying maybe that's our Q there. Okay, we say maybe that's our Q here. Okay, now if that's our Q, maybe let's say the P, our P maybe, let's say somewhere here. So our P is somewhere here. Now, so this point of intersection here, the coordinates there are negative P and Q. Always is negative P and Q in your equation. So you must understand that these two, once you have these 2 points, you will now be able to say, all right, my line of symmetry are these two lines here. Okay, this one is y equal to x plus c1, and this one is equals to y is equals to negative x plus c2. So in this case here, the negative here, the x and y, you just need to substitute the coordinate that you get here. You substitute there to get the c2 and the c1. Okay, that's what you're supposed to do. Okay, I'm just gonna show you an example there. Okay, so here we said, what is our asymptote? Y asymptote is 9. We'll just pick here, This is our 9 here. It's an asymptote. That's what you just need to remember when you're given an equation. And what is our asymptote here is negative P. Negative P, what is negative P? Is negative 3, because here there is 3 already. So what we have here is that we have 9 here, we have -3 here. So in this way, in other words here, what the coordinates here are, the coordinates for this point here are -3 and 9. Okay. Now, what we need to find here is the finding equation of symmetry. The equation of symmetry. So we know that they're going to cross like that. Okay. And the second one is supposed to be like that. So these two are perpendicular. These two lines are perpendicular. It means that they meet at 90. And if you multiply their gradients, it gives you what you call -1. So now let's see what you're supposed to do here. You're going to say, all right, to find the equation of symmetry, you know that you have got coordinates here. You know that it's what you call is supposed to be y is equal to -x. So for the first one here, let's call this one a, let's call this one b. So for a, okay, we're going to say is equal to x plus c1. And let's substitute now the coordinates of what we call the center there, the point of intersection. Okay, so point of intersection is -3 and 9. Okay, so to find our c, we're going to substitute this, substitute 3 and 9, okay, to get c. Now we're going to say 9 there is equal to what is -3, okay, it's gonna be what, plus c, okay, then minus is going to give us positive. Then if we take that side, it's going to be negative. It's going to be c is equals 9 minus 3, which is equal to 6. That's what we have there. So our c is equal to 6. Then on equation b on the other end, okay, it's y is equal to x plus c. Because why are we saying that? Because it's an uphill. If you remember very well, it's an uphill. It's positive gradient. Then the other one is downhill, which is a negative gradient. Y is equals to x plus c. Then we substitute again our point -3 and 9. Okay, we're going to say 9 is equals to negative. What is it? 3. What is it? Where are we now? Negative x plus 9. All right, yeah, -3 plus c. So if it is negative here, it's up, when it moves that side, it's going to be what? It's going to be positive. Okay, then it's going to be c is going to be 9 plus 3, which is equals to 12. Okay, so that's what we get there. So our c is equal to 12. So in other words, the first equation here, the first equation is supposed to be for a, it's y is equal to negative x plus 6. Then for this one, y is equals to x plus 12. Okay, so these are the two equations of symmetry that we have there. So for b, these are the two equations of symmetry. So we've got y equal to what is it for the negative one? -6, negative x, sorry, plus 6, and this one is y is equals to x plus 12. That's it. So these are the things that you always have to remember. That what is it when you're calculating your lines of what you call axis of symmetry. That's what you just need to recall here, to say the equation of symmetry for a hyperbola is, there are two of them, and how do you get them? This is what you're supposed to do. Okay. Okay, so whenever you're sketching, you must remember to check the sign of A. The sign of A will determine which quadrant your graph will fall. And after that, you need to determine the asymptotes. Remember how you get the asymptotes. The asymptotes are your negative P and what called and Q. Those are the asymptotes. Okay. Then from there, you must also check what you call the intercepts, y and x intercept, where we say y-intercept is for x equal to 0. You say when x equals to 0 and when y is equal to 0. That's how you get this x and y-intercept Okay, so sometimes you cannot find them, okay, because what called doesn't touch those both of them like the standard one. Now domain and range, you need also to tell what is the domain, what is the range there. So let's see if we can have what called an example here. All right, we have got y is equals 5 over x plus 10. And in this case here, we can see that is positive. So we know that, oh, our graph is going to fall into the first and third quadrant, which is good. Now, asymptote here, we know that asymptote is q. Okay, in this case, it's q. And x equal to what called x is equals to what is it? X cannot be 0. So x equal to 0 is another asymptote. So asymptotes here, asymptotes y equal to 10. Okay, remember, because it's q and x is equal to 0. So when you draw your graph, you know that these two, your graph must not touch, okay, must not touch the y equal to 10. Your graph also must not touch, what is it, your equation, your function must not touch what called the line x is equal to 0. Now, what about the y-intercept? Okay, y-intercept, we say y-intercept. So this is number 1. Number 2, y-intercept. Y-intercept when x is equal to 0. What do? We can't have here, we can't put a 0 there. We can't have a 0. So this one is a no. Okay, no. Now here, what about, what is it, the x-intercept? Is when y is equal to 0. Oh, we can have 0 there. We can say 0 is equals to 5 over x plus 10. Okay, then you multiply by 5 by x throughout, by x throughout, by x throughout. Then what do we get there? We're going to say 5 over x is equal to negative 10. Multiply both sides there, it's going to be 10. 5 is going to be equals to negative 10x. Then we divide both sides by negative 10. X is going to be equals to 5 over negative 10, okay, which is equals to negative 1 over 2. That's what we have as an x value there. So our coordinate there, you know that, all right, it's going to pass it negative 1 over 2, negative 1 over 2, 0. That's the coordinate, okay? Then domain, let's determine the domain after drawing the function, okay? Okay, now what do we have here? We've got x, we've got y. Okay, what are we told here? We're told that x is equal to 0 is an asymptote. So x is equal to 0 is this y there, okay, the y-axis. So in general, y-axis doesn't touch. And when y equal to 10, okay, when y is equal to 10, that's another asymptote. Okay, that's another asymptote there. Is it correct there? Yeah. When y is equal to 10, so we say that one is an asymptote. So in other words, we shifted our graph. We shifted our graph by 10 units upward, okay? By 10 units upwards, remember, it's a Q. Now, from there, what else do we have there? So what is it? We know that the graph is going to touch it what x is equals to negative half, negative 1 over 2. That's what we know, okay? And we've got a 0 there. Now, what are we going to do now? We know that it's a positive, so it falls in the what? In the first quadrant, so it's going to be like this. It doesn't touch the x, the y equals to 10. It doesn't touch also the x, the y-axis, okay, because those are the two asymptotes there. But now you remember, you can see that it's going to touch it's going to touch the x-axis in this case. So it's going to cross at what? Going to cross at negative 1 over 2. That's where it actually crosses there. Okay, so that's where it crosses. In other words, here you actually done with what called you're almost done. Let's see the domain. Let's see the domain there. What is going to be our domain there? Domain, we know that the domain is the x values, okay? X values. So in terms of x values, we just know that x must not be equal to 0. That's what we know. And x is element of real numbers, okay? That's what we know. Then what about the range, okay? In that case, so the range there in terms of y, you can see that x, y cannot be equal to 10. So we just simply writing the asymptote here. Y cannot be equal to 10, okay? And y is element of real numbers. Because it can attain any value here, the y it can attain any value here except 10, because a 10 there is actually an asymptote, okay? So this is the first article. This is the first sketch, and let's see if we can sketch something else again. Okay, I hope you guys understand how you're supposed to sketch here. Okay, so we have another example there. F of x is equals to, in the form of what we call a over x plus p q, and not something here. We said asymptotes, the coordinates of asymptote point of intersection is negative p and q. And the equation for asymptotes are, these are your equations. Okay, y is equals to q and x is equals to negative p. So always remember that, okay? Now, let's see what we have here is that f of x is equals to negative, okay? And this negative, what does negative tell us? It means that our graph is gonna be in the second and fourth quadrant. Okay, that's number one. That's very good to know. Okay, now the second thing, let's look on the asymptotes. Asymptotes, we know that asymptotes is going to be y equal to 8. Okay, should I write asymptotes first? Sorry, asymptotes are y equal to 8 and x is equal to, what is it, negative p. Negative is going to give us positive negative, which is 4. So x equals to 4 and 8, y is equals to 8. That's our asymptotes, okay? X is equals to 4 and y is equals to 8. And what else do we need to know there? We want to know the y-intercept. Okay, y-intercept is when x is equal to 0. Okay, now x can be 0 here, so we can say y is equals to negative 3 over 0 minus 4, because we said 0 plus 8. And what do we get there? Let's see what we get there. Let's see what we get there is negative 3. Okay, negative 4. All right, now is it fine there? Okay, plus 8. What do we get? We get 35 over 4. That's our answer there. Now that's our y in terms of y, and let's see in terms of decimal is 8,75. That's fine. Then let's check with, what is it, with the y-intercept, the x-intercept. For x-intercept, x-intercept y is equal to 0. What are we going to do now? We're going to say, all right, we have our equation there. We're going to say negative 3, okay, 0 is equals to over x minus 4 plus 8. Okay, so what do? We multiply, we remove the denominator here by multiplying throughout by, we say x minus 4 times here x minus 4 times here x minus 4. That's what we're supposed to do here. So we're going to say it's going to be 0 is going to be equal to negative 3, because this one is going to cancel. It's going to cancel each other, plus 8 x minus 4. Okay, then we're going to get what? We're going to say 8x is going to be 8x minus 8 times 4 is 32, is fine. 8 times 4, 32 minus 32, okay, minus 3 is equal to 0. Now we take this one, that side, 8x is going to be equals to minus 32 minus 5 plus 2. 35 is going to be 35. We move that side, is going to be positive 35, and the x is going to be equals to 35 over 8. Okay, 35 over 8, that's our value of x. Okay, so we know that very well that these are the values that we have, and what we have coordinate, the coordinate here is going to be 0, 35, 4, and in this case it's going to be 35, 8, and 0. Those are the coordinates of what we need here. Okay, the domain, we'll talk about the domain when we are done sketching. Okay, so let's see here what we're going to do. So hyperbolic functions, they are actually easy to deal with, because everything is given to you there. You can pick it from just looking. Now here we are told that asymptotes is y is equals to 8. I just have to go to 8. 8. Okay, now y x is equals to 4. I just have to go at 4. What do I do now? Just draw lines. That's all. This one, what I know, asymptote. Then here I also draw the asymptote. Okay, now when I draw the asymptote, this means that this is my new center there. Okay, now your graph here, you can see that the graph is going to touch what? It's going to touch, what is it? It's going to touch the what is it? Is in the what? It's in the second quadrant and fourth quadrant. So it's going to be here. And what I need to know that is that my graph is going to look like this. It's going to look like this. Okay. And the other one is going to look like this. Yeah, that's what we have here. And remember what we find here, we find the y-intercept. Y-intercept is 0 and 35 over 8. 35 over 8. So we know that there at this point here is 35 over 4, sorry. 35 over 4. And what we have here is 35 over 8. And if we say 35 divided by 8, what do we get? We get 4 comma something, okay? So it's very much close there. So it's 35 here over 8. Those are the coordinates that we have. So by writing something like this, so we have got y equal to 8, and you've got x equal to 4. Okay, these are the asymptotes. And once you have the asymptotes, you have got the coordinates, the y, the intercepts, y-intercepts and x-intercepts, and your what is it? Your sketch is actually fine like that. Now let's talk of the domain here. What is our domain in terms of x? Let's check the domain here. What are the values that are satisfied with the x? So you can see that x actually doesn't approach 4, okay? But from there it can go up to infinity. Then again, this on top here, you can see that x just approaches 4 but doesn't touch 4, but it goes until what you call until negative infinity. So we can just say, all right, x not equal to 4, but our x is element of real numbers. Now, what about the range? Range in terms of y, you can see that in terms of y, your x there, it doesn't, the y value is actually doesn't touch 8. And but from 8 there, it approaches an infinity. Then here again, it doesn't touch 8, but from 8 downwards, it does approach what called touches negative infinity. So we're going to say y not equal to 8. And by saying y not equal to 8, our y is element of real numbers. Okay, so it actually satisfies other real numbers except 8 and except 4 here in this case. That's our domain, that's our range, that's what you're supposed to do. Okay, that's all what you need to understand here for what you call when you're doing your sketches. Okay, guys, so this is the end. Thank you so much. Okay, don't forget to subscribe and follow us on the following social platforms. And also, if you have any questions, you can feel free to contact us on our WhatsApp and also on our cell. Okay, so I'm Stole. Until next time, guys, thank you so much. Cheers.